Hello everyone. But today we'll do this topic, mathematical induction. Okay. Now, what is mathematical induction? Is basically mathematical induction is a mathematical technique. Is a mathematical technique to it is used to prove mathematical statement. Okay, mathematical statement which holds true for all natural number. Okay, mathematical induction is basically a mathematical technique which is used to prove mathematical statement which holds true for all natural numbers. Okay, means what it does. See, for example, suppose the statement is like this. Okay, mathematical statement is this. 1, let's say first statement is 1 plus 2 plus 3 up to n is given by n into n plus 1 by 2. Okay, this statement is true for all natural numbers. Okay, this statement is true for all natural numbers. Okay, so in fact we can check this proof. Okay, by using, if you observe these numbers carefully, 1 2 3 all natural numbers. Okay, and the difference is what, starting from 1 2 then 3 then 4, so difference is these are consecutive natural numbers, difference is 1. Okay, see, we can apply these numbers are in AP, basically APGP. Remember sequence and series beta 10th grade. Okay, in APGP, if the terms are in AP, the sum is given by n by 2 2a plus n minus 1 into d beta. So this is n by 2, n natural numbers are there, 2a, a is the first term, so 1, n minus 1, d is what, d is also 1 beta, so this is n by 2, 2 plus n minus 1, so n by 2, n plus 1. Okay, that's the answer. Okay, but we are not proving by this sequence series method. Okay, we are checking the proof by using mathematical induction method. Okay, so for every question in mathematical induction, what we have to do, always write it down given statement as t of n. Okay, in mathematical induction, for every question what we'll do, we'll write it down every statement as t of n. Okay, so we'll write it down this statement, this full thing is known as a mathematical statement, so t of n. Okay, so t of n, okay, is 1 plus 2 plus 3 up to n, n into n plus 1 by 2, n into n plus 1 by 2. Okay, now what we'll do, beta, in this case, okay, now we'll prove this using mathematical induction method. Okay, now what is mathematical induction method? Is actually, this method is based on like assumption. Okay, so this method based on 3 steps. Okay, for each and every question, in mathematical induction we need to follow 3 steps. Okay, step 1. Okay, so for each and every question in mathematical induction we need to follow 3 steps. So step 1 is we have to prove that this statement, given statement, is true for n equal to 1. Okay, n equal to 1. Okay, we have to prove that this statement is true for n equal to 1. Okay, so if n equal to 1, what is left hand side, beta? N equal to 1 represent what, beta? N equal to 1 represent first term. Okay, n equal to 1 represent first term. So in this, what is the first term? First term is 1. Okay, so first term is 1. So left hand side is 1. Okay, yeah, n equal to 1 represent the first term. Okay, because you have 1 2 3 like this we have, therefore LHS is 1. Okay, suppose it is like this 2 4 6 like this we have, so n equal to 1, if this is t of n, so n equal to 1, if you take, then your LHS will be what, beta? 2. Okay, because the first term is 2. Okay, yeah, suppose it is like this, 1 cube plus 2 cube plus 3 cube and so on, 3 cube, okay, n cube, okay, equal to something. Okay, so n equal to 1 represent what? The first term, so n equal to 1 will be what, beta, in this case? 1 cube, which is 1. Okay, yeah, so in this case LHS we got it, beta, in this case n equal to 1 represent the first term, so first term is 1 only. Okay, what about RHS, beta? So RHS, n equal to 1 we substitute here in RHS, n equal to 1 we substitute, so 1 into 1 plus 1 upon 2, beta, so 2 by 2, which is 1. So LHS equal to RHS. Okay, so t of n is true for n equal to 1. Okay, t of n is true for n equal to 1. Okay, till here you understood, beta? See, mathematical induction, each and every question is based on 3 steps. Okay, we need to follow 3 steps. So step 1 is n equal to 1. So understood step 1. Step 2 is always an assumption. Step 2 is always an assumption. Okay, step 2, we to assume that step 2 is an assumption. We have to assume that t of n is true for n equal to k. Second step is always an assumption, okay? In mathematical induction, second step is always an assumption. So we assume that P of n is true for n equal to k, okay? We assume, okay? We don't know, okay? We just assume that it is always true, okay? This is mathematical induction, 1 plus 2 plus 3, like this, n is replaced by k. This is k into k plus 1 by 2, okay? N is replaced by k. We assume that P of n is true for n equal to k means what? In P of n, okay, just replace n by k. Everywhere just replace n by k. That's it, okay? Yeah. So second step is always an assumption. Okay? And then the step 3. So actual answer is basically the step 3 only. Okay, so step 3 is what? Now we will prove that P of n is true for n equal to k plus 1. Now we will prove that P of n is true for n equal to k plus 1, okay? P of n is true for n equal to k plus 1 beta, okay? Now this proving part is always done with the help of this assumption and the step 1, okay? So this proving part is always done with the help of this assumption, this earlier steps, okay? Please remember now, so we have to prove that P of n is true for n equal to k plus 1. Okay, so if I replace n by k plus 1 beta, what will you get? P of k plus 1 is equal to 1 plus 2 plus 3, like this. N is replaced by k plus 1 now, okay? N is replaced by k plus 1. Okay, so this, wherever there is n is replaced by k plus 1. So n is replaced by k plus 1. This is k plus 1 by 2. So this is k plus 1, k plus 2 by 2. Okay, n is replaced by k plus 1 beta. N is replaced by k plus 1. Okay, now, see beta. 1, this is 2, this is 3. So can you tell me the next term? Next term will be 4. After that, which term will come? After 4, 5. So if I say this is 7, let's say there is 7. So 1 before that will be what? 6. 6, if I say 6, so before that 5th term, okay. So if this is k plus 1, so before k plus 1, which term will be there beta? Before k plus 1, always k term comes, isn't it? Before k plus 1, always k term comes. Understood till here, like this, see. It is 1 plus 2 plus 3 plus, like this. So if I write like this, 6, 7, 8, 9, okay. Okay, and so on. Okay, so if I say 9 here, so before 9, obviously 8th term comes, okay. If this is 8th term, so before this 7th term is there. So if this is k plus 1 term, so before k plus 1, obviously kth term comes, isn't it beta? Yeah, so now we have to prove this. We have to prove this is equal to this with the help of this assumption beta, okay. So if I prove, how to prove this? Okay, if I start with LHS now, LHS is what beta, see. 1 plus 2 plus 3 k, okay, k plus 1. But what is 1 plus 2 plus 3 up to k beta? From step 2, what is 1 plus 2 plus 3 up to k? Is k into k plus 1 by 2? Isn't it? It is k into k plus 1 by 2. And this k plus 1 will keep as it is, okay. So here k into k plus 1 into 2 by 2, we can take k plus 1 common, so k plus 1 common, so what is left is k plus 2 by 2, which is equal to beta RHS, isn't it? Which is equal to RHS, which is equal to this, we got it. And therefore, hence, by using principle of mathematical induction, this statement is true. Is this clear to everyone beta? You have to write it down, huh? Hence, by using principle of mathematical induction, following statement is true for all n belongs to natural number. For all n belongs to natural number. This is true for all n belongs to natural number. Is this clear to everyone? Beta, understood? Slowly you understand. All questions are of the same type beta. Okay, this is very mechanical topic. Okay, once you understand 1, 2 question, then automatically understand all questions. Very mechanical. Okay, see, always write it down given statement as t of n. Always write it down given statement as t of n. Then you have to write it down. We have to follow 3 steps always. Step 1, step 2, step 3. Step 1 is always n equal to 1. Step 1 is always n equal to 1. what? N equal to 1 represent what? N equal to 1 represent first term. N equal to 1 represent first term. Okay, so find out LHS, RHS will be always true. Then second step is always an assumption. Second step is always assumption. Okay, we have to just replace N by K, that's it. And we assume this is true. Okay, we assume this is true. Okay, and step 3. We have to prove that given statement is true for N equal to K plus 1. So if the last one is K plus 1, one before that is always K term. Okay, if K plus 1, so one before that is always K term. Okay, in RHS replace N by K plus 1, simplify, and then we prove this LHS equal to RHS. Is this clear to everyone, beta? Understood properly, everyone? Yeah, good. Now beta, see the second question will prove. Okay, so this was the first question. Okay, now second. Pay attention, beta. Exactly same, all questions like this only, beta, we are doing. Okay, so this is a very mechanical topic. Okay, now see the second question, beta. Very simple this chapter is. Okay, now see the second question we'll do. Second question is beta. Okay. Second question is this is first ka second sub question. 1 square plus 2 square plus 3 square to n square is equal to n plus 1 to n plus 1 by 6. Okay, n into n plus 1 into 2n plus 1. Okay, n into n plus 1 to n plus 1 by 6. Okay, this we want to prove. Okay, see what I told you, beta. See, always write it down given statement as t of n. This is mathematical statement, so t of n 1 square plus 2 square plus 3 square n square is n into n plus 1 to n plus 1 by 6. Okay, now we need to follow 3 steps. Step 1, let n equal to 1. Let n equal to 1. So LHS is what? First term. First term is 1 square. 1 square is 1. RHS is 1 into 1 plus 1, 2 plus 1 by 6. So that is 1 only. So LHS equal to RHS. Okay, so T of n is true for n equal to 1. Step 2. Step 2 is always an assumption, beta. Step 2 is always an assumption that T of n is true for n equal to k. Step 2 is always an assumption, let T of n is true for, okay, we assume that T of n is true for n equal to k. So then replace n by k, T of k, 1 square plus 2 square plus 3 square. Okay, k square is equal to k into k plus 1 to k plus 1 by 6. Okay, now step 3. Step 3 is a proving part, beta. Step 3 is a proving part. Okay, see, for each and every question you have to follow these 3 steps. Step 1, n equal to 1. Step 2 is assumption, and step 3 is proving part. Now we will prove that T of n is true for T of n is true for n equal to k plus 1. Okay, so T of k plus 1 is what, beta? Is 1 square plus 2 square. Like this, replace n by k plus 1, so k plus 1 square. So if this is k plus 1 square, so 1 before that will be k square, isn't it? And now replace n by k plus 1, beta. So this is k plus 1, okay, is equal to, actually n is replaced by k plus 1, k plus 1 plus 1, 2 times k plus 1 plus 1 upon 6. So basically this is equal to, like, T of k plus 1 is 1 square plus 2 square, k square plus k plus 1 whole square is equal to, this is k plus 1, k plus 2, 2k plus 2 plus 1, that is 2k plus 3 upon 6. So we have to prove that this equal to this. Okay, we have to prove that this equal to this. Okay, and this proving part is always done with the help of this assumption, beta. Okay, so now to prove this, LHS, I'll write it down. LHS is 1 square plus 2 square, k square plus k plus 1 whole square. But beta, what is this? 1 square plus 2 square up to k square is what? K into k plus 1, 2k plus 1 by 6 is nothing, k into k plus 1, 2k plus 1 by 6, and this is k plus 1 the whole square. We can take k plus 1 common. Okay, and at the same time I'll take LCM also. So this is k, 2k plus 1 6 times k plus 1 upon 6. Okay, so this is k plus 1, 2k square plus k plus 6k plus 6. Okay, so this is k plus 1, 2k square plus 7k plus 6. Okay, now we're going to factorize this. 6 2s are 12, 4 and 3 are the factors. So this is k plus 1, 2k square plus 4k plus 3k plus 6 upon 6. So this is k plus 1. I'll take 2k common, so we'll get k plus 2. 3 common, k plus 2. So basically this is k plus 1, k plus 2, k plus 1, k plus 2, 2k plus 3 upon 6. Okay, which is equal to RHS. Which is equal to RHS. Hence, by principle of mathematical induction, do not forget to write this statement. Hence, by using principle of mathematical induction, T of n is true for all n for all. Hence, by using principle of mathematical induction, do not forget to write principle of mathematical induction. T of n is true for all n belongs to capital N. Is this clear to everyone, beta? Understood this? Yeah? Good. Okay, beta, now see the third question. Okay, third question is 1 square plus 3 square plus 5 square 2n minus 1 whole square is equal to n by 3 2n minus 1 2n plus 1. Okay, this we have to prove, okay, using principle of mathematical induction. So what I told you, in principle of mathematical induction, every statement will assume as T of n. Okay, so represent every statement as T of n. So write this statement as T of n. 1 square plus 3 square plus 5 square n by 3 2n minus 1 2n plus 1. Okay, then we have to follow 3 steps, beta. Then we have to follow 3 steps. Okay, so step 1. Step 1 is what? Let n equal to 1. Okay, let n equal to 1. Okay, so LHS is what? N equal to 1 represents the first term. So your first term is 1 square. So that is 1. RHS is what? RHS is 1 by 3, 2 minus 1 and 2 plus 1. So that is what? 1 by 3, 1, 3. So which is 1. Okay, LHS equal to RHS. So T of n is true for n equal to 1. Okay, always we have to prove that T of n is true for n equal to 1. Okay, second step is always an assumption. Step 2. Step 2 is always an assumption. Okay, so what is assumption we do here? That T of n is true for n equal to k. Let T of n is true for n equal to k. Okay, so so we just replace n by k. Okay, we replace n by k. T of k is equal to 1 square plus 3 square. We replace n by k, 5 square. Okay, is equal to k by 3, 2k minus 1, 2k plus 1. Okay, till here you understood, beta? Understood till here? Okay. Now, step 3. Step 3 is actually proving part. Let T of, now we'll prove that T of n is true for T of n is true for n equal to k plus 1. Okay, this we have to prove. Okay, so T of k plus 1, T of k plus 1 is equal to 1 square plus 3 square. Okay, this is 2k minus 1 whole square, 2k minus 1 whole square is equal to, we have to replace n by k plus 1, so k plus 1 by 3, 2 times k plus 1 minus 1 and 2 times k plus 1 plus 1. Okay, okay. This is when n is equal to k, not k plus 1, because n equal to k is this, na? So this is for n equal to k. So what about k plus 1 will be? There is one more term will come. 2 times k plus 1 minus 1 whole square. Okay, is this clear? Okay, this part is still n equal to k, na? So this part is still n equal to k. After this there is one more, k plus first term is also there, na? So the next term will be replace k by k plus 1. So there is one more term is there. Okay, understood, na? Okay. Like say in the first question I told you the first term is 1, then 2, then 3, like this. Then 4 comes, then 5 comes. Okay, so if I say next term is 6. So before 6 term is 5th term. Okay, so like this the term is k plus 1. So before k plus 1 the term is k always. Before k term will be what? K minus 1. Okay, so now till kth term is this. So k plus first term will be what? If the kth term is this, k plus first term will be, just replace this k by k plus 1. So this is still kth term and this is k plus, because now n equal to k plus 1. So till k plus 1 term we have to write it down. This is 1 term, this is 2 term, like this is kth term. So this is k plus first term. Okay, so we have to write it down in the third step always till k plus 1 term. Okay, we have to write it down till k plus 1 term. Okay, so this is basically 1 square plus 3 square, 5 square, 2k minus 1 whole square plus 2k plus 2 plus minus 1 plus 2 minus 1 is plus 1 whole square is equal to, this is k plus 1, 2k plus 1, this is 2k plus 3 upon 3. So now we have to prove that this equal to this. Okay, we have to prove that this equal to this with the help of an assumption, with the help of this assumption. Okay, so now let us start with LHS beta. LHS 1 square plus 3 square plus 5 square dot 2k minus 1 whole square plus 2k plus 1 whole square. Okay, but what is this beta from step 2? See, what is this from step 2? From step 2 it is k into k by 3, in fact k by 3 2k minus 1 2k plus 1, and this is 2k plus 1 the whole square. I'll take 2k plus 1 common beta and I'm taking LCM also 2k. So k 2k minus 1 3 times 1 2k plus 1 is outside, so 1 upon 3. Okay, so this is 2k plus 1. Okay, this is 2k square minus k plus 6k plus 3 upon 3. Okay beta, so this is 2k plus 1 2k square plus 5k plus 3 upon 3. So beta, we can factorize this 2k plus 3k. Okay, so 2k plus 1, this if you factorize you will get 2k plus 3k, 2k common, okay, k plus 1. So basically I'll get this only, na? Which is equal to RHS. Yeah? Say 2k plus 3k and in 2k common, so you get k plus 1 from 3k, 3 common, k plus 1, so k plus 1 common, 2k plus 3, okay, which is equal to RHS. Hence by principle of mathematical induction, T of n is true for all n belongs to capital N. Is this clear to everyone beta? Understand everyone? Yeah, pretty simple. This chapter is very mechanical, okay? Very mechanical, okay? We are doing same thing for each and every question. Exactly same thing only we are doing for every question, okay? We always write down given statement as T of n, then we prove it T of n is true for n equal to 1. Second step is always an assumption, okay? That is T of n is true for n equal to k, and then we prove it T of n is true for n equal to k plus 1 with the help of second step, okay? Always. Now see the next question beta, fourth question. Okay, beta see the fourth question is 1 into 2, 2 into 3. But this is 1 into 2, huh? Not 1.2. This is 2 into 3, not 2 point, yeah? So 1 into 2, 2 into 3, okay, 3 into 4. Now you can think like, you know, why we are writing 1 into 2, why not directly 2, why we are writing 2 into 3, why not directly 6? Because it following some pattern, okay? To show that pattern, like 1, then 2, then 2, then 3. So in general, if it is n plus 1, the next one is n plus 1, okay? Is always multiplied to get the resultant as n into n plus 1, n plus 2 upon 3, okay? Now let us see how to prove this, okay? Again, same way, always write it on given sentence as statement as T of n, 1 into 2, 2 into 3, 3 into 4, n into n plus 1, n plus 1, n plus 2 by 3. Okay, so let T of n is step 1. Let n equal to 1, n equal to 1. So LHS is what? First step. N equal to 1 represent first term beta. Now first term is this. First term is 1 into 2, that is 2. What about RHS beta? RHS is okay. RHS is 1, 1 plus 1, 1 plus 2 by 3. So 2, 3. Okay. So T of n is true. T of n is true for n equal to 1. Okay. Step 2. Step 2 is always an assumption. T of n is true. Let T of n is true for n equal to k. Okay, second step is always an assumption beta, so we assume that T of n is true for n equal to k. Okay, T of n is true for n equal to k. Okay, so replace n by k. T of k is equal to 1 into 2, 2 into 3. Okay, like this. K into k plus 1. This is k plus 1. Okay. Then we have step 3. Step 3 is what? Now we'll prove that T of n is true for n equal to k plus 1. Okay, so T of k plus 1 is what beta? See how to write it down. T of k plus 1. You just write it down this step 2 as it is. Okay, you just copy this step 2. 1 into 2, 2 into 3, 3 into 4. Okay, like this k into k plus 1. So this is kth term. This is kth term. We want to write it down till k plus 1. Now. So next term is k plus first term. Okay. So till kth term is this. Okay. Now k plus 1. How to obtain k plus first term? Replace k by k plus 1. So you get k plus 1. And then this will become k plus 2 automatically if I replace k by k plus 1. So here what will happen? So here it is k plus 1. Then this is k plus 2 we'll get k plus 3 upon 3. Okay. So now we have to prove that this equal to this. Okay. With the help of this step. Okay. So, left hand side here, 1 into 2, 2 into 3, 3 into 4, k into k plus 1, okay, plus k plus 1 into k plus 2. Okay, but what is this from step 2? This is nothing, k into k plus 1 into k plus 2 by 3, right? K into k plus 1, k plus 2 by 3. Plus k plus 1, k plus 2. So k plus 1 we can take common, k plus 1 common. So what is left is k into k plus 2 by 3. This is k plus 2. Okay. So k plus 1, k square plus 2k plus 3k plus 6 by 3. So this is k plus 1. I'll take k common, k plus 2 here, 3 common, k plus 2. Okay. Actually we could have done directly k plus, there is no need. We can take k plus 1 into k plus 2 also directly, no common. Directly I'll take k plus 1, k plus 2 common. K plus 1, k plus 2 common, so what is left is k by 3 plus 1. So that is k plus 1, k plus 2, k plus 3 by 3, which is equal to RHS. Okay, hence by using principle of mathematical induction, T of n is true for n equal to, for all n belongs to capital N. Is this clear to everyone, beta? Understood? Yeah? Good. Okay, beta, now let's do next question. Number 5, fifth sub question. Okay. 1 into 2, 2 into 2 square, 3 into 2 cube, like this. N into 2 raised to n. Okay, n into 2 raised to n is equal to n minus 1 2 raised to n plus 1 plus 2. Okay, this we have to prove. Okay, so always write given sentence, given statement as T of n. So T of n, 1 into 2, 2 into 2 square, 3 into 2 cube. Okay, like this, n into 2 raised to n is equal to n minus 1 into 2 raised to n plus 1 plus 2. Okay, so now we need to follow 3 steps. Step 1, step 2, step 3. Okay, beta. Step 1 is always n equal to 1. Let n equal to 1. Okay, n equal to 1. So left hand side is what? N equal to 1 represent the first term. First term is 1 into 2, that is 2. Okay. What about RHS beta? RHS will be N equal to 1. RHS is 1 minus 1, 0 plus 2, that is 2. LHS equal to RHS. Therefore, T of N is true for N equal to 1. Okay, T of N is true for N equal to 1. Is this clear to you? Okay, T of N is true for N equal to 1. Step 2. T of N. Step 2 is always an assumption. Beta step 2 is always an assumption. Let T of N. Let T of N is true for. Let T of N is true for N equal to K. Okay, so T of K is equal to 1 into 2, 2 square, 3, 2 cube, K 2 raised to K, K minus 1, 2 raised to K plus 1 plus 2. Okay, and this is assumption. Okay, now step 3. Now we will prove that T of N, T of N is true for N is equal to K plus 1 beta. Okay, so T of K plus 1 is 1 into 2, 2 into 2 square, 3 into 2 cube, like this, K into 2 raised to K. This is up to kth term. Now we have in step 3 we have to write it down till K plus 1 term. Okay, so this is kth term. So K plus 1 term will be what? Replace K by K plus 1. So K plus 1 into 2 raised to K plus 1, okay, is equal to, replace K by K plus 1. So K plus 1 minus 1. So that is K only. So K 2 raised to K plus 1 plus 1, that is K plus 2 plus 2. Okay, so you have to prove this. Understood this part? This part you understood beta. What we are doing basically, we are replacing N by K plus 1. So K plus 1 minus 1, 2 raised to K plus 1 plus 1 plus 2. So this is K 2 raised to K plus 2 plus 2. Understood this? Yeah, by replacing N by K plus 1. Okay, now beta, we want to prove this, right, with the help of step 2. So LHS is 1 into 2, 2 into 2 square, 3 into 2 cube, K into 2 raised to K plus K plus 1 into 2 raised to K plus 1. Now what is this from step 2 till here? Is nothing but this now, is K minus 1, 2 raised to K plus 1 plus 2, and this is K plus 1 into 2 raised to K plus 1. This term as it is. Okay, now see this plus 2 I'll keep as it is, and between these two terms, I'll take 2 raised to K plus 1 common beta. Between these two terms I'll take 2 raised to K plus 1 common. Okay, so what is left is K minus 1 plus K plus 1, 2 raised to K plus 1 plus 2. So 1 get cancelled, this is 2K. 2K, 2 raised to K plus 1 plus 2. Okay, 2K can be written as 2 into K, right? 2K is nothing but 2 into K. Okay. Now let us see, remember law of indices, a raised to m into a raised to n is a raised to m plus n, power gets added. So 2 raised to 1 into 2 raised to k plus 1 is 2 raised to, okay, is 2 raised to k, I'll keep it as it is, 2 raised to 1 plus k plus 1, and this 2 as it is. So k, 2 raised to k plus 2, which is equal to RHS. Is this clear to everyone? Beta, understood now? Here law of indices is used, okay? Because 2 into 2 raised to k plus 1 power decided. 1 plus k plus 1 is k plus 2, okay? Which is equal to RHS, which is equal to this, and hence by using principle of mathematical induction, T of n is true for all n belongs to capital N. Is this clear to everyone? Beta, understood properly? Everyone? Yeah? Good. Now let's see next question, beta. I hope beta you are understanding this properly. Yeah. Everyone understood beta trigonometric equations and trigonometric properties of triangle. Everyone understood beta properly. If you have any difficulties, please ask me. Huh, beta? Please ask me. Don't feel shy. Don't hesitate. Just call me, beta. Okay. I hope this chapter also till now you understood very much. Okay. And now next question we are doing question number 6. Sixth question. Okay. Sixth sub question is 1 into 4 into 7. This is not 1.4.7. This is 1 into 4 into 7 plus 2 into 5 into 8, 3 into 6 into 9, like this, and n plus 3, n plus 6. n into n plus 3 plus n plus 6 is always equal to n by 4, n plus 1, n plus 6, n plus 7. But you will try this yourself. You will try? Yeah? Everyone will try this question? No? It's okay, let it be. I'm solving this beta. Pay attention, everyone. Pay attention, I'm doing it. It's okay. Pay attention beta now. Exactly same as the previous question beta. Exactly same as the previous question. It follows 3 steps. Always write it in given sentence as the statement as t of n. So now here only I'm writing, let's say this is t of n. Okay. So let step 1 n equal to 1. N equal to 1 represents first term beta. First term is 1 into 4 into 7. That is 7 4s are 28. Okay. What about RHS beta? If you find out RHS will be, RHS is what beta? RHS is 1 by 4, 2, 7, 8. So that is how much? 56 2. This is 28 only. Okay. Isn't it? Yeah, 4 2s are. Okay, so 7 2s are 2. Okay, 28. Okay, so LHS equal to RHS equal to RHS, and therefore T of n is true for n equal to 1. Okay, step 2 is always an assumption beta. Step 2 is always an assumption. What assumption we do? That T of n is true for n equal to k. T of n is true. T of n is true for n equal to k. Okay, so this is T of, replace n by k. 1 into 4 into 7, 2 into 5 into 8, 3 into 6 into 9. Okay, k into k plus 3, k plus 6 is equal to k by 4, k plus 1, k plus 6, k plus 7. Okay, beta? Yeah? Okay, this is step 2. Step 2 is always an assumption. Now step 3. Step 3 will prove that T of n is true for n is equal to k plus 1. Okay, T of n is true for n equal to k plus 1 beta. Okay, so now replace n by k plus 1. So this is 1 into 4 into 7, 2 into 5 into 8. Like this, k plus 3, k plus 6. Now replace n by k plus 1. This is still kth term. K plus 1 term will be what? K plus 1, k plus 4 you will get, k plus 7 you will get, is equal to k plus 1 by 4. This will be k plus 2, this is k plus 7, and k plus 8 you will get it. Okay. Now we have to prove this. Okay, this part, proving part is done always with the help of this assumption. Step 2. Okay, so LHS 1 into 4 into 7, 2 into 5 into 8. Okay, k plus 3, k plus 6, k plus 1, k plus 4, k plus 7. Okay, beta? Now what is this? From step 1. In fact, step 2. What is this? This is nothing but k by 4, k plus 1, k plus 6, k plus 7. Plus, this is k plus 1, k plus 4, k plus 7. Okay, k plus 1, k plus 4 and k plus 7. Yeah. Now we can take k plus 1 and k plus 7 common. Okay, k plus 1 and k plus 7 common. K plus 1, k plus 7 common. What is left is k plus 1 gone and k plus 7. So k into k plus 6. 4, k plus 1, k plus 7 gone. 4 times k plus 4, I am taking LCM also, upon 4. Okay beta, k plus 4 is left there. So this is k plus 1, k plus 7. This is k square plus 6k plus 4k plus 16 by 4. So that is, this is 10k. 10k plus 16, no? 10k plus 16, beta, can you factorize k square plus 10k plus 16? Okay, see, I'll just show you the factors separately. K square plus 10k plus 16 is 8 2s are 8k plus 2k. I'm just showing separately. K common, k plus 8, 2k plus 8. So this is k plus 8, k plus 2. Yeah, so k square plus 10k plus 16, this is k square plus 10k, na? This is 10k plus 16. Can be written as directly k plus 8, k plus 2 upon 4 is there, beta. Look at this. This is nothing but this, na? K plus 1, k plus 2, k plus 7, k plus 8, k plus 1, k plus 2, k plus 7, k plus 8 upon 4, which is equal to RHS. Therefore, T of n is true for n equal to k plus. Therefore, T of n is true for all n belongs to natural number. Is this clear to everyone, beta? Understood properly? Yeah? Good. Now, beta, next question, number 7. So, 7 sub question is 1 into 3, 3 into 5, 5 into 7, 2n minus 1, 2n plus 1 is equal to n 4n square plus 6n minus 1 upon 3. Okay, this we want to prove. So what we'll do, beta, always write given statement as T of n. So T of n. This is 1 into 3 and not 1.3. Okay, now I hope everyone knows this very much. Step 1, LHS n equal to 1 will take. Okay, so 1 into 3, that is 3. RHS will be 1, 4 plus 6 minus 1 by 3. So 10 minus 1, 9 by 3, that is 3. So LHS equal to RHS. Therefore, T of n is true for n equal to 1. Okay, T of n is true for n equal to 1. Okay, T of n is true for n equal to 1. Then step 2. Step 2 is always an assumption, beta. Let T of n is true for n is equal to k. So replace n by k. So T of k, 1 into 3, 3 into 5, 5 into 7, 2k minus 1, 2k plus 1 is equal to k, 4k square plus 6k minus 1 upon 3. Okay, beta? This is clear to you? Now, see the next step. Step 3. Step 3 is always proving part. So let T of n is true for T of n is true for n is equal to k plus 1. T of n is true for n is equal to k plus 1. Okay, so T of k plus 1 is equal to, okay, 1 into 3, 3 into 5. Like this, kth term is 2k minus 1, 2k plus 1. But this is kth term, so k plus first term will be what? If this is kth term, k plus first term will be what? Replace k by k plus 1. Equal to, replace k by k plus 1. 4 times k plus 1 whole square, 6k plus 1 minus 1 by 3. Okay, see, if you simplify this, no matter what we will get, I'll just check. If you simplify this part, I'm just doing this part rather than doing everything here. Na? So, 4 k plus 1 whole square plus 6 k plus 1 will be what, beta? 4. This k square plus 2k plus 1. This 6k plus 1. Okay. So 4k square plus 8k plus 4 plus 6k plus 6 minus 1. So 4k square plus, how much this is? 14k? 10 minus 9. So 4k square plus 14k plus 9 beta this is. And this also, left hand side is what? 1 into 3, 3 into 5. Okay, 5 into 7. Like this. 2k minus 1, 2k plus 1 plus this part. So 2k plus 2 minus 1, that is 2k plus 1, 2k plus 3, okay, is k plus 1 into 4k square plus 14k plus 9 upon 3. 4k square plus 14k plus 9 upon 3. Okay, so now we want to prove that this equal to this beta. Okay, we have to prove that this equal to this. Okay, so we'll start with LHS beta. So if I say this is LHS, okay, look at this part till here from step 2. This part is what beta? This is nothing but this. This is nothing but k into 4k square okay and this is what you will get 2k plus 1, 2k plus 3. Okay, fine. Nothing common. We can't take anything common now. We can't take anything common. Fine, then we have no other option but to open the brackets. Okay, 4k cube, 6k square minus k. This is 3 times. Okay, 4k square plus 6k plus 2k. Okay, 6k plus 2k, that is 8k plus 3 upon 3. So this is 4k cubed plus 6k square minus k plus 12k square plus 24k plus 9 upon 3 beta. Okay, so if you simplify this, this is what 4k cube plus how much this is 6k square plus 12k square, that is 18k square, 4k cube plus 18k square plus 23k. Okay, we got this. We have to prove that it is equal to this. So what we'll do, I'll open this bracket also. Okay, so then this was 4k cube plus 14k square plus 9k plus 4k square plus 14k plus 9 by 3. So that is 4k cube plus 14 plus 4, that is 18k square, 9 plus 14, that is 23k plus 9 by 3. Yeah, LHS equal to RHS, we got it. LHS equal to RHS, hence T of n is true for n equal to T of n is true for all n belongs to capital N. Is this clear to everyone, beta? Understood properly? Yeah? Understood now? Because here it was not possible to take anything common, so what we did? We just expanded everything. And this also we expanded, and we got LHS equal to RHS. Understood now? Good.